Okay, so this is another Higgs video, and it's part of a little mini series. I think this is the third one, so you might want to backtrack 2 more videos. Neutrinos, mirrors, Higgs mass particle pulse laser beam collider, CERN TTL APPG. September 30th, 2012 is when I started working on it. Today's November 16th, 2012 is when I'm filming it. My thoughts. In the last video we looked at E-TTL neutrinos, and this is a continuation of the data. The title of the previous video is E-TTL Neutrino Oscillations, Higgs, ICARUS, Detector, Dodecahedron, Leonardo, da Vinci. So a PPT file emulsion for neutrino factory possibility of the technology. dpnc.unige.ch, and it's future neutrino research possibility of the technology. KEK beam test preliminary 50 GeV electrons plus muons electron ID. Okay, I think this is where I started working on the muons, the MU2E videos as well. That's another series I started when I started looking on muons to electrons and started cross-referencing the alien well data with the Higgs data to see what was coming up. Okay, so you can look at those videos. A lot of them are up on the ICARUS YouTube channel already. So here's the PDF, arxiv.org, that came up from M.N. Tonello, 2012, so it's a new one. Measurement of the neutrino velocity with the ICARUS detector at the Department de Física and Fin University de Pavova. I'm running out of battery power here. So there's precision measurement of the neutrino velocity with the ICARUS, same website. Proposal for first ever measurement of coherent neutrino nucleus, that's from reports.ext. Detection of coherent neutrino nucleus scattering. Electrons, let's go scoot down here. August 20th, my thoughts. This is one we want, the TTL burst pattern input trigger 3ms mode, arbitrary TTL pattern. So I'm going to Google Tektronix 73A270 main features and specifications. And I don't think I'm going to get through this video in time. September 9th, creating a pulse signal with mirrors and beams. You do 3 separate flashes to catch the small particles you wouldn't normally see. The flash will illuminate the particle and create a shadow with the next flash, and if you zoom in, you'll be able to see it. This is for the neutrinos. Split 4 leptons, add mass neutrinos into 4 quarks theory, and a Higgs boson mass particle, plus all the formulas to give it the mass it needs to see and study it. So you're going to want to go to wiki, Okay, so I ran out of battery power on this Higgs boson video, so this is part 2 of this video. Neutrinos, mirrors, Higgs mass particle pulse laser beam collider, CERN TTL APPG. So I already did all this section here. I was looking at the different links, and I kind of cut through it real quick. Precision measurement of the neutrino velocity with ICARUS came up. A proposal for first ever measurement of coherent neutrino nucleus electronics for the LAMP neutrino experiments veto counter. Design and initial performance of the Ascarian radio array. A fast chopper for the Fermilab high intensity neutrino source. So what I do is I take the keywords from these and use them in the, you know how I look for keywords, and that's how I come up with the formula ideas. So what we want is the TTL burst pattern input trigger 3ms mode, arbitrary TTL pattern. And then I was going to Google Tektronix 73A270 main features and specifications on www.used-line.com. And there's the thing. So quotes, the 73A270 arbitrary pulse pattern generator. APPG module is a printed circuit board assembly for use in a card cage conforming to the VXI bus specifications such as the 73021 using the CDS 73A IAC system. The module provides 2 completely independent output channels with a common backplane interface. Okay, so we have an idea of what it can do. It's got an inactive TTL or bipolar analog pulse, so it's got pulses to it. It's got high-speed memory. So the ability of the APPG to output short pulses repeatedly or short pulses delayed by long intervals make it ideal for triggering other VXI bus instruments using either front panel connectors. Okay, so that's usedline.com. And again, September 9, 2012, to reiterate what this was about, was my thoughts are to create a pulse signal with mirrors and beams. You do 3 separate flashes to catch the small particles you wouldn't normally see. So this is what we're looking for the neutrinos. You're looking for those smaller particles, either with neutrinos or with the Higgs boson particles, like the other bosons that we're looking for the standard model. The flash will illuminate the particle and create a shadow with the next flash, and if you zoom in, you'll be able to see it. This is for neutrinos. Split 4 leptons, add mass, neutrinos into 4 quarks theory, and add a Higgs boson mass particle, plus all the formulas to give it the mass it needs to see it and study it. So the whole point of the Higgs video is to find a way to make a Higgs particle last longer than a split second. Okay, so that's the end of this part 2 of this video, and we'll go on to the next one. Thanks for watching.